Learning objective E and F, we're going to make an appropriate graph to determine if a distribution is bell-shaped and to talk about shape center spread. And then we're going to use that 68, 95, 99.7 rule to assess normality of a data set. This is probably a little bit more of a typical way people would assess normality versus creating that normal probability plot, which is not required on the AP exam. It's the only example we're going to look at, so let's take some time with it. It says here 20 students were asked to guess the age of a man in a photo. Here are the guesses that they had. Are these guesses approximately normally distributed? Appropriately provide enough evidence. Now, if you're given data, the one thing they're always going to say is you have no idea what this data looks like unless you graph it out. So you must graph out the data if you do not have a graphical picture of it. And that is why chapter 1 is so important and why we did it first. So you can do the dot plot or a histogram for this. You could do a box plot if you wanted to. I think I'm going to go ahead and put the data in a calculator and sketch out a box plot. So let's do that. And I'm actually going to choose a modified box plot so it can do the outlier test for me. Now, when I do this, here's what I end up getting. So here's the box plot. We do have the minimum value on this at 33 and we're at maximum of 50. Quartile 1 is at 40.5. The median is at 43 and my quartile 3 is at 45.5. Now based on this shape, it looks somewhat symmetric. It might be slightly skewed to the left a little bit, but maybe not too much. So based on the graph, I'm not exactly sure. Again, somewhat symmetric. So that's basically what we did is learning objective E here. Say it's somewhat symmetric, maybe slightly skewed to the left. The center is going to be somewhere in here, and we can see the range in our spread. But let's go ahead and do that 68, 95, and 99.7 rule. That's going to be a little more precise. So to do that, I want to think about one standard deviation away. So we need to actually take this data and get the mean and standard deviation from it. So using my calculator, I'm going to do the stat calc, a one variable statistic for the mean and standard deviation. Again, a great review from chapter 1. When I do that, the X bar for my data is at 42.75, and my standard deviation on here, we will go out to 4.15. Now to start our analysis, to be at 68%, we want one standard deviation away. So the range I want to look at for that are any of the values between 38.6 and 46.9. So I'm going to look at the data here and count up all of them out of all 20 students and see what percent reside in that range. Now if you do that, I'm going to roughly look at the values from 39 to 46 because of our rounding. So 39 to 46, I circled all of the values that fall between 39 and 46. And out of here there's 14. So 14 out of 20 of them, and that actually gives me 70%. So for the first criteria, about 68%, it's darn close. So I like the one standard deviation. Let's check two standard deviations. We know 95% of the data should be two standard deviations away. That range would be the values between 34.45 and 51.05. Again, I just took this value, subtracted another standard deviation, and I took this one and added another standard deviation to get the good range. So we're not quite at 34, so we need to look at values between 35 and 51. And when we do that, that tacks on these 5 more, so now we're at 19 of 20 observations meet that requirement. And in terms of a percentage, that actually is 95%, so that's looking really good. And then the last one would be 3 standard deviations away. So if we do 3 standard deviations, that's going to be 99.7% of the data should sit there at 3 standard deviations. And that range is going to bring us at anything in between 30.3 to 55.2, and that will include this last piece of data. So that's going to get us at 100%. So based on the 68, 95, 99% rule, we could say that this data is approximately normal.